Okay, we're going to talk about Objective 6, demonstrate an understanding of geometric relationships and spatial reasoning. And I know I'm going to split this up into a couple different podcasts. So here we go, looking at number 19. Look at the cube shown below. Which equation best represents the area of the shaded rectangle located diagonally in the cube? And if we look at our answer choices, look very vague, very general, like letter A is A equals S squared times the square root of 3, and so forth. So let's just look at it and see what's going on. First of all, we're trying to find the area of a rectangle, and if you'll recall that the area is equal to length times width. So we have to define what the length and width are. What we can see in a cube, since this is a cube, all of these edges of the cube are the same dimension. There's an edge, so forth. All of these edges of the cube are going to be the same dimension. And since that's the case, what that tells us then is that each edge of the cube here is S, and so that means this up here is going to be S as well, and that turns out to be the length of our rectangle. So now what I need to do is I need to find the length of my rectangle. So let's look at the length of our rectangle here. The length of the rectangle, this thing right here, if you'll notice, is actually going to be the hypotenuse of this right triangle. If I'm looking at the face of the cube, the front face of the cube is this right here, and therefore this is the hypotenuse of a right triangle that makes up half of the front of the face of the cube. And using that information, again, this is S, this is S, I can find my hypotenuse here using Pythagorean theorem. Remember that says a squared plus b squared equals c squared. And in this case, my a squared and b squared is going to be my s's. So I have s squared plus s squared equals, and then I need to know what my hypotenuse is over here. So I can just call that c if I want, or in this case what I'll do, since it's my width, I'm going to call it w. W squared. So I need to know what w is. So I need to just solve for w. Well, combine like terms here. I have an s squared here and I have an s squared here. Put them together and it gives me a 2s squared equals w squared. Still solving for w, so I take the square root and I get w is equal to the square root of 2s squared. Almost done. Almost have my width completely simplified. Since I have an s squared underneath here, and this is a radical here, these actually are inverse functions of each other, the square root and the s being squared. So what happens is one of the s's just comes out and I'm left with a 2 inside. So w is equal to s times the square root of 2. So what I found is that my length is going to be s, and my width is going to be s square root 2. So then my area is equal to, let me just write that down real quick. We found that our length is going to be s, found that right there, and we found that w is going to be s root 2, and we found that right there. So my area is going to be equal to length times width, which is going to be s times s root 2. Simplified gives me s squared times the square root of 2, which is answer choice D. Number 33. Look at the figure below, and it says which expression does not represent the area of the figure. So the key word here is going to be not. Which expression does not represent the area of the figure? So let's look at the area of the figure. Since we have a L looking shape here, it's probably best if I like to approach these kind of problems like this and just reconnect that piece there and see what we can find. So if I'm looking at the entire area here, since I'm looking for the one that's not the area, it's probably best to go through these answer choices and see which one doesn't make sense. That's probably the best way to approach it. So A says BC minus EF. So if I have BC, if I multiply B times C, that gives me the area of the whole thing here, which I've created with this green dotted line and the rest of the rectangle. So that's the whole area, and subtract out EF. E times F represents this square that's going to be subtracted away, so we really got lucky here. A is definitely